In this video, we'll look at an assignment problem. The example that motivates it is assigning home healthcare aides, where we have a distance matrix, we have 10 aides, we have 10 patients, and each aide is going to spend a full day caring for each patient. We want to minimize the total travel time. Let's say we're paying for the hours or the mileage traveled. So let's say we want to minimize the total distance traveled by aides in our organization. Our decision variables are actually going to be whether we assign each aide to each patient. We're going to have 100 binary variables. We have 100 because it's 10 aides times 10 patients. And our main constraint is that each aide is going to be assigned to one patient, and each patient is going to be assigned to one aide. So we have a couple of sum functions to work on here. I'm going to take the sum for aide 1 and make sure that for this assignment, for this aide, every aide gets assigned to one patient. And then in row 33, we're going to add up the number of assignments for each patient to make sure that each patient gets assigned with one aide. I'm going to say sum. I'm going to sum up the column. And I'm going to copy that across. So now I have 10 patient assignment constraints, 10 aide assignment constraints, and I'm going to minimize my total travel time. So what's the travel time of aide 1? Well, the travel time of aide 1 is going to be, for this temporary decision variable that we have here, this made up initial solution where each aide is assigned to the corresponding patient number, 1 to 1, 2 to 2. Well, here aide 1 is going to be traveling 1.41 hours. If we wanted to automate that, we could use the sum product function. I'm going to multiply all of aide 1's potential assignments times all of the corresponding travel times. And because it's a 0-1 variable, it's always going to give me the right travel time. I'm going to copy that down for the other 9 aides, and then I'm going to add them up. Sum of these 10 calculations. So for this assignment, there's 19 hours of travel time per day. I would go to my model. Let's reset my model. I want to minimize my travel time. Click min. I'm going to change my variable cells. These 100 decision variables I have here. I'm going to have constraints that each aide only goes, or each patient only is assigned one aide. And I'm going to add constraints that each aide is only assigned to one patient. So that is my 10 sum values in column M are equal to these constraints of 1. I'm going to put those in the solver, minimizing the total distance. I'm going to click OK. And solver is going to find me a solution. The solution is 4.9 hours. So I can see what the travel times are for my aides. It is 0.2 is the shortest travel time, and one of them does have to travel 1.3 hours. But when you add them all up, you come to 4.9 hours. Now let's talk through some wrinkles in the model to see how the solution would change from 4.9 hours if I had a bunch of additional constraints that might reflect specific business situations. So first constraint, let's say that we have different types of aides, different types of patients. Let's say aides 1 through 4 have a special skill that patients 8, 9, and 10 require. So here we need patient 8 to be assigned by an aide 1, 2, 3, or 4. So I'm going to, for patient 8, I'm going to select aides 1, 2, 3, and 4. I'm going to make that the sum of J23 to J26. For aide 9, I'm going to do the sum of K23 to K26. And for aide 4, I'm going to, or for patient 10, I'm going to go to column L and sum L23 to L26. It looks like patient 8 is already getting an assignment from one of these 4 aides, otherwise, but the other 2 are not. So let's add those constraints and solve. I'm going to add these 3 constraints that they are equal to 1. Click OK to solve. And let's see, now we have patients 8, 9, and 10 getting aides 1, looks like 1, 3, and 4 to be assigned to them. Next, let's look at a couple more constraints. Let's say aides 9 and 10 have special support roles, so one of them needs to be in with patients 1 through 5, and one of them needs to be in with patients 6 through 10. Suppose patients 1 through 5 are in one geographic area, patients 6 through 10 are in another. Well, if we want one of either 9 or 10 with patient group 1 through 5, then the number of aides from 9 or 10, the number of assignments among aides 9 and 10 to groups 1 through to patients 1 through 5 has to be 1. So I'm going to say this is equal to, that cell C46 is equal to the sum of these 10 cells here, C31 to G32, and that C47 is equal to the sum of H31 to L32. Right now, both aides 9 and 10 are with patients 1 through 5. So when we add that constraint and resolve, let's add the constraint, add 2 constraints. That C46 and C47 are equal to E46 and E47. I'll click OK and solve. And now I get an answer that where aide 9 is with groups 1 through 5 and aide 10 is with 6 through 10. Let's say aide 8 is not allowed to be assigned to patient 2 unless there's a support person at patient 1 or patient 3. And if we have constraints that look like some sort of a requirement constraint, then we're going to use a less than or equal to. So whether there's a support staff at 1 or 3 is going to equal to C31 plus C32 plus E31 plus E32. Is aide 1 at patient 2? Or aide 8 at patient 2? Okay, we're going to make that's going to be equal to D30, that's that assignment. So the way this less than or equal to sign works is that if there's no support staff at 1 or 3, then this has to be 0. Aide 8 can't be at patient 2. However, if there is support staff at patient 1 or 3, then aide 8 is allowed to be 0 or 1. So then it can be assigned to patient 2. Right now this constraint is violated. Let's add it and resolve it. To add that C51 is less than or equal to E51. Click OK. Solve, and solver finds that it's just not worth having aide 8 at patient 2. They don't want to take away support staff to change around whether there's support staff at 1 and 3. Okay, let's link to the travel time. So we're going to link to cell Q32. So cell C55 is equal to Q32. I'm going to link that down. Let's see if, let's say our max travel time is 2 hours. Add constraints, see if we can resolve it. So cells C55 to C64 are less than or equal to E55 to E64. Click OK. Let's solve. And now we've changed things around so that no one works or no one travels more than 2 hours. Finally, maybe we want to minimize the maximum travel distance of any of our 10 aides instead of just minimizing the total. How we would do that is to create another column here in column S. Each of these, the total travel times is going to be less than or equal to our maximum. We're going to, let's make this the maximum here in this cell. This is going to be in, so now S33 is going to contain our maximum. The way I'm going to do this is to introduce 10 constraints and change our decision variable. We can't just take our total here and make our objective to be the minimum of these cells rather than the sum. That's just not allowed in the world of linear programming. You can't use a minimum function, but or a maximum function. We want to minimize the maximum here. So let's say the maximum, I don't know, let's say it is 3. We're going to be changing this around. We're going to tell Solver to make this as low as possible. The way we do that is we make this actually both an output and our decision variable. We're going to tell Solver to change this, make this low as possible, such that it is still bigger than each of the travel times. So how we're going to do that is each of these cells S23 to S32 is going to be linked to our maximum. So I'm going to make these our linked styles here, and we're going to introduce some new constraints. Okay. So let's go to Solver. Our objective instead of minimizing the total, now it's going to be minimizing our maximum. So we're minimizing S33. And now instead of the 100 decision variables, we're going to have 101 decision variables. The maximum is something that we are changing ourselves. We can only make it as low as the biggest travel time because of these new 10 constraints that we're adding for each of our aides. So Q23 to Q32 is less than or equal to S23 to S32. Click OK, and let's solve. Okay. Now Solver found that the maximum of our travel distances is 1.79 or 1.8. So one of these is exactly 1.79, and this is a solution in which we've minimized the maximum travel distance of our 10 aides.